Hello, 8th grader. How are you today? I hope all of you in a good condition, in a good, healthy, and always happy. Today we learn about work. The competency standard in this chapter is understanding the concept of work, simple machine, and its application in everyday life, and connection with the work of muscle on human skeletal structure. What is work? When we say work, maybe you are thinking about homework. Sometimes we mean exercise. Other times we mean a place we go every day and do something to earn money. But in physics, definition of work is very different. In physics, work is action done on an object that displaces the object. Work is done when there is a force and displacement. No work without motion, no work without force in the same direction. The formula of work, look at the picture. The man pushes the table from one position to another position with force F. The man is doing work. Work equal force times displacement. Force is vector quantity. Vector quantity is a quantity has magnitude and direction. Displacement is vector quantity too, but work is scalar quantity. Scalar quantity is quantity has only magnitude without direction. The symbol of work W, the symbol of force F, and the symbol of displacement D. So W equal F times D. F is force applied with unit newtons. D is displacement with unit meters. W is work with unit joule. 1 joule equal 1 newtons meter. 1 joule equals the amount of work that is done when 1 newtons of force move an object over a displacement of 1 meters. Force must be parallel or in the same direction as motion. Work is classified into three types. The first, positive work, second, negative work, and the third, zero work or no work. Work can be positive or negative depending on whether the force is in the same direction as displacement or in the opposite direction. Positive work. Work is positive if the applied force in the same direction as the displacement. Negative work. Work is negative if the applied force is in the direction opposite the displacement. Look at the picture. If the boy pushes the table to the left and the table moves to the left, the work is positive because the, the direction of force and displacement are the same. But the work of the friction thus is negative because the direction of friction is opposite the direction of displacement. The third, zero work or no work, when the force acting on the object is perpendicular to the direction of displacement. Picture 1. Force applied by man to carry object does no work because the object does not move in the direction of the force. Direction of motion perpendicular to the direction of the applied force. Picture 2. The man pulls the wall, but the wall doesn't move. Force exerted by man on the wall does no work because no displacement. Work done equals zero as force and displacement are perpendicular to each other. Work done is positive if force and displacement have the same direction. Work done is negative if the direction of force is opposite the direction of displacement. Look at the picture below. There are two boys. You and your friend push the box. You push the box to the right and your friend push the box to the left. And the box move 1 meters to the right. F on box by you equal positive 3 newtons because the direction force of U is the same the direction of displacement. And then work on box by U equal 3 joule from F times D. 3 newtons times 1 meters equal 3 joule. F on box by your friend equal negative 1.5 newtons because the direction force of your friend is opposite the direction of displacement. Work on box by your friend equal negative 1.5 joule from F times D. Negative 1.5 joule times 1 meters equal negative 1.5 joule. In vertical, normal force equal m times g. Normal work equal 0. Why? Because the box move in horizontal. If the force doesn't parallel with the displacement but it forms theta angle, like the picture below, then the formula of work equal Fx times d. Work equal F cos theta times d. Theta, the angle between the force and the displacement. For example, number 1. Consider the picture below. The magnitude of the work done by the object M is known. F1 equal 150 newtons to the right. F2 equal 200 newtons to the right. F3 equal 175 newtons to the left. Displacement or D equal 180 centimeters equal 1.8 meter. Unknown work equal solution. The first way is the total work equal work 1 plus work 2 plus work 3. Work 1 equal F1 times D equal 150 newtons times 1.8 meters equal 270 joule. Work 2 equal F2 times D equal 200 newtons times 1.8 meters equal 360 joule. Work 3 equal F3 times D equal negative 175 newtons times 1.8 meters equal negative 315 joule. The total work equal 270 plus 360 plus negative 270 joule. The total work equal 315 joule. The second way is work equal net force times D. Work equal F1 plus F2 minus F3 times D equal 150 plus 200 plus minus 175 newtons times 1.8 meters equal 175 newtons times 1.8 meters equal 315 newtons meters equal 315 joule. Number 2. The object pushed by 20 newtons force and then moved with acceleration 0.8 meters per second square for about 10 seconds. Magnitude of work to push the objects is known. F equal 20 newtons, acceleration 0.8 meters per second square, T equal 10 seconds, Vi, initial velocity is 0, unknown work. Solution, work equal force times displacement. Displacement equal initial velocity times time plus half times accelerations times time square. D equals 0 times 10 seconds plus half times 0.8 meters per second square times 100 seconds square. D equals 0 plus 40 meters equal 40 meters. So, work equal 20 newtons times 40 meters. Work equal 800 joule. Okay, class. I hope all of you understand about work. And now you are doing exercise from your teacher. Thank you for your attention and God bless you.